Assalamu alaikum, dear students. Welcome to Mathematics Online. Today in this lecture, we will be solving some exercises based on the previous concept. That's algebra of complex numbers. Here we have first question. It is express each of the following complex numbers in exercise 1 to 10 in the form of a plus ib. A plus ib means it is a standard form. So we have to express these complex numbers in the standard form. So how can we do that? It's like this. You have this complex number. It's 5i minus 3 divided by 5 into I. We will be using simply laws of algebra. So it is minus 5 into 3 by 5 into I. So it is 5 and 5 goes. We are left with minus 3. I into I, that's I square. So it's minus 3 into I square is minus 1. It is equal to 3. So this complex number is equal to 3. You can write it 3 plus 0 into I in the form of a plus ib. Okay. Next question is you have to express the number I raised power 9 plus I raised power 19 in the form of a plus ib. How can we do that? Simply we have to use the laws of indices. We have to break this I raised power 9. We can break it like this. I raised power 4 into 2 plus 1. I raised power 19 is equal to 4 into 4 plus 3. So this is equal to I raised power 4 into 2. You know that I raised power 4 is equal to 1. And this is I as such. It's I raised power 4, that's equal to 1. 1 raised power 4 is 1. So it's I raised power cube, that's minus I. So it's I plus minus I, that's equal to 0. So this complex number is equal to 0, or you can write 0 plus 0 into I. Okay. Similarly, we have other questions. Say we have I raised power minus 39. You can express it. I have solved it here. You can see it. Next question is question number 4. We have to express this question in the form of a plus ib. And this question is 3 into 7 plus I7 plus I times 7 plus I7. So you see this question, we have to simply use the distribution law here. So we will distribute 3 over 7 plus I7 and I over 7 plus I7, and we get this expression. After that, we will make necessary calculations and we get 14 plus 28 into I. Okay. So this is in the form of a plus ib, where a is equal to 14 and b is equal to 28. Similarly, we have question number 5. You can solve this. It's very simple. Next, we have question number 6. Once again, we have to use here laws of algebra. Here, we are supposed to use the difference law. We will subtract real from real and imaginary part from imaginary part, and we get this. Okay. Next is question number 7. In question number 7, we are supposed to use first of all, inside the braces, we are supposed to use the addition law and then subtract the this minus 4 divided by 3 plus I from the resultant, and we get this 17 divided by 3 plus I times 5 divided by 3. Next is question number 8. It's 1 minus I raised power 4. Here we have to use the laws of indices. So laws of indices can be used like this. It's 1 minus I square whole square. Use here the square law. So it's a minus b whole square. This is equal to a square plus b square minus 2ab. So it's simply its expansion is minus 2i. Okay. Then after here it's square, we will multiply it twice. So it is 2 into 2, that's 4. I into I, that's I square. It's minus 4. So this can be written in the standard form as minus 4 or minus 4 plus 0 into I. Similarly, we have this question. It's in the form of cube. So we will use the cube law for indices. Okay, we will expand this and write in the form of a plus ib. You see question number 10 is also same. It can be solved on the same lines. Next is question number 11. Question number 11 is find the multiplicative inverse of the following complex number. How can we find the multiplicative inverse? Multiplicative inverse can be found by z inverse is equal to, that is z conjugate divided by modulus of z square as per the definition. So z conjugate, I have earlier discussed it. Conjugate is the complex number, given complex number with its change in the imaginary part. It's actually the reflection of the given complex number. Okay, and modulus, how can we calculate that? That's under root of real part square plus imaginary part square. That's 25. So it is 4 divided by 25 plus 3 divided by 25 into I. Okay. Next is question number 12. We have to find the multiplicative inverse here also. So on the same lines, we can find it. You see this. Next is question number 13. Once again, we have to find the multiplicative inverse. The procedure is same. It's z bar divided by mod of z square. Z bar is the conjugate of the complex number, and mod z is the modulus of the given complex number. Next is question number 14. In question number 14, once again, we are supposed to find the write this complex number in the form of a plus ib. So how can we? It's also on the same lines. Very simple. It's not any hard task to do. Hope that you have got it. If you have any confusions in understanding this, you are most welcome to ask your queries in the comment section. Thank you for joining the class.